Okay, Assalamualaikum. Salam sejahtera. So now we proceed to the next chapter, which is chapter 6 in your Form 4 Chemistry KSSM syllabus, which is acid, base and salt. Okay, so this chapter will include acid, base and salt. Okay, next. What you will learn in this chapter, the first subtopic is the role of water in showing acidic and alkaline properties. And then 6.2, you will learn about pH value. Then you will learn 6.3, the strength of acid and alkalis. 6.4, chemical properties of acid and alkalis. 6.5, concentrations of aqueous solution. And 6.6, standard solution, how to make a standard solution. Then you will go through 6.7, which is neutralization. 6.8, salt crystal and their uses in daily life. 6.9, preparation of salt. 6.10, effects of heat on salt. And the last subtopic is 6.11, qualitative analysis of salt. So today we go to the first subtopic, which is the role of water in showing acidic and alkaline properties. Why water is needed. Okay. So in our learning standard, at the end of the lesson, you are able to define acid. You able to define acid. What is acid? Able to define alkali. What is alkali? And then state the meaning of basicity of acid. What is basicity? Okay, and then investigate the role of water in showing acidic and alkaline properties through experiment. Okay. So look at this situation. A son asks his dad, how can I make this coin shiny again? So the father suggests try scrubbing with lime. What is in lime? Normally we know lime is fruits that sour taste, so normally contains acid. And then the son asks his mom, why do we need to brush our teeth every morning? Why? Because we need to neutralize the acid in our teeth. And you know that what we call toothpaste is alkaline. Okay. Next. Based on Arrhenius theory, acid is a chemical substance that ionizes in water to produce hydrogen ion. So this is the definition of acid. Acid is a chemical substance that ionizes in water to produce hydrogen ion. So this one is definition. Okay. Tulis pun salah. Okay. Okay, look at example. Hydrogen chloride in aqueous will ionize to produce hydrogen ion and chloride ion. Another example, nitric acid, aqueous. When the state is aqueous, that means it is dissolved in water. So it will ionize to form hydrogen ion and nitrate ion. Okay. So that's why in the definition we state that acid is a chemical substance that ionizes in water. So actually what happened? Hydrogen ion produced will combine with the water molecule to form hydroxonium ion. So you have learned dative bond. Okay, hydroxonium is an example of dative bond. Okay, which is hydrogen ion will go to water molecule and attach to the lone pair of electron in the oxygen atom. So it will produce hydroxonium ion. Actually, hydroxonium is the responsible ion for acidic properties. Okay? That's why water is needed. Without water, there is no hydroxonium ion because hydrogen ion cannot make dative bond without water. Okay? So, although hydroxonium ion are actual ion that give acidic properties, but to simplify the equation, to make you easier to write chemical equation, normally we just represent hydroxonium ion as hydrogen ion. Okay, that's why as you can see, this is equation and this equation for ionization of hydrochloric and nitric acid. We don't write hydroxonium. We want to simplify it. Okay. Okay, next. Basicity of acid. Okay, acid classified into three basicity. Okay, the first one is monoprotic acid. Mono means one. And then we have diprotic acid, which is 2. And then triprotic acid, which means 3. Okay. Example of monoprotic acid is hydrochloric acid, because hydrochloric acid, when ionized, it will produce 1 hydrogen ion per acid molecule. So, maksudnya kalau HCl ionized, it will produce 1 hydrogen ion and 1 chloride ion per molecule. Diprotic acid, for example, is sulfuric acid, because sulfuric acid, H2SO4, when ionized in water, will produce 2 hydrogen ion and 1 sulfate ion per molecule. Okay. So, phosphoric acid. Phosphoric acid, when ionized in water, will produce 3 hydrogen ion and 1 phosphate ion, okay, per molecule. Okay. So, normally monoprotic acid are hydrochloric acid, nitric acid. Sulfuric acid is considered as diprotic and phosphoric acid as triprotic. Okay, besides that, formic acid. Formic acid, other name is methanoic acid, is used in coagulation of latex. Is formic acid is a diprotic acid? As you can see in the formula, we have 2 hydrogen ion. So, you may be consider it as diprotic. But, formic acid is monoprotic acid because only hydrogen that bonded to oxygen will ionize to form hydrogen ion. Another hydrogen that bonded together with carbon does not ionize. Okay, it's still considered as monoprotic. Okay, next we go to alkalis. Okay, so in this chapter, this chapter is acid, base, and salt. So what is base? Base is a substance that reacts with acid to produce salt and water only. So base normally is oxide metal or hydroxide metal. Okay? That can react with acid to produce salt and water only. Okay. Look at this one. Observe the chemical equation below. Magnesium react with hydrochloric acid to produce magnesium chloride and hydrogen gas. Is magnesium a base? The answer, no. Because base is a substance that can react with acid to produce salt and water only. But in this reaction, it reacts with acid to produce salt and hydrogen gas. Okay? So, magnesium is not a base. Actually, magnesium is a metal. Okay? A base that is soluble in water is called alkalis. Potassium hydroxide, sodium hydroxide are alkalis because they are soluble in water. When sodium hydroxide pellet, okay, normally in the lab, the sodium hydroxide we get from the chemicals supplier, normally in pellet form. This one pellet. Okay. It's dissolved in water, so sodium and hydroxide ion in sodium hydroxide can move freely in water. So in solid, sodium ion and hydroxide ion is in fixed position. But in water, the ion will move freely because it dissolves or soluble in water. Okay. So alkali is chemical substance that ionize in water to produce hydroxide ion. This one is definition of alkali. Alkalis, okay? So what will happen to ammonia molecule when ammonia gas is dissolved in water? So ammonia NH3 when react with water, what will happen? Hydrogen from water will make dative bond with ammonia to form ammonium ion, and water will become hydroxide ion. So this reaction will produce hydroxide ion, which give alkalis property. So in this situation, same as acid, they need water to show its alkalis property. Okay, uses of acid, base, and alkalis in agriculture. Okay, fertilizer consists of salt. And as you can see, if the soil is too acidic, like paddy field, normally we add a base, okay, to neutralize the acidic soil. And then in industry, this one is car battery. We use sulfuric acid as electrolyte. Antacid use normally a base to neutralize acid in stomach when you have a gastric. And then food industry, okay, we have benzoic acid, we have carbonic acid in gases, carbonated drink. Okay, toothpaste normally contains alkalis. pickles, normally we use vinegar. And vinegar is an acid. Okay. So now we go to the role of water in show acidic and alkalinity. Okay, so this situation, the girl find that the soap taken out from box not slippery. Then the mother told to add some water. Okay, so by experiment we can show acidic and alkaline properties. So experiment 6.1, to study the role of water in showing acidic properties. Okay, problem statement. Is water needed to allow an acid to show acidic properties? As you can see, problem statement, there is a question mark here. Okay, then hypothesis. Water is needed for an acid to show its acidic properties. So our manipulated variable, presence of water, responding color change on blue litmus paper, and fix is type of acid. So we have material here, solid oxalic acid, distilled water and blue litmus paper, and then apparatus, test tubes and test tube wrap. Okay, procedure. Add a spatula. Okay, of solid oxalic acid in a test tube. Then insert a piece of dry litmus paper into test tube. Observe any changes to the color of the blue litmus paper and then record. Don't forget to record. After that, add 2 cm cube distilled water. Okay, when there is a liquid, we must mention the volume. And shake well. Observe any change to the color of blue litmus paper and then record your observation. So result, for solid oxalic acid, blue color of litmus paper remains unchanged, while solid oxalic acid, when added with water, blue color of litmus paper changed to red. So state the change in color of blue litmus paper that is used to detect acidic properties. If you want to detect acidic properties, the color of litmus paper must change from blue to red. Okay. So based on the observation, state the suitable inference. So our inference, solid oxalic acid does not show acidic property, but solid oxalic acid that has been dissolved in water shows acidic properties. So what are the conditions needed for an acid to show its acidic property? So water. Okay. So is the hypothesis acceptable? Yes. What is the conclusion for this experiment? Water is needed to show the properties of acid. Okay. Next, we go to discussion. Okay. Name the ion that responsible for showing the acidic properties. The question asks name. So the answer should be hydrogen ion. Must write the name. Okay. Solid oxalic acid had different in observation compared to the solid oxalic acid that has been dissolved in water. Give a reason. So, without water, solid oxalic acid exists in the form of molecule. So, no hydrogen ion. Thus, oxalic acid does not show acidic properties, and the blue litmus paper remains unchanged. When oxalic acid is dissolved in water, the oxalic acid molecule ionizes to produce hydrogen ion. So, hydrogen ion will show acidic properties. So, blue litmus paper change to red. So, next, what is the operational definition for acid? Operational definition, that means what you do, what you observe. Okay, here the operational definition. An acid is a substance that change blue litmus paper to red when the blue litmus paper is dipped in an acid that has been dissolved in water. So, blue litmus paper turns red. This one is what you observe. Okay, blue litmus paper is dipped in acid that has been dissolved in water. Ini what you do. Okay, so itu dinamakan operational definition. So, what we can conclude here, acid only show acidic properties in the presence of water. When an acid is dissolved in water, acid molecule will ionize to produce hydrogen ion. The presence of hydrogen ion allow acid to show its acidic properties and change blue litmus paper to red. Without water, acid only exists as molecule. So, hydrogen ion are not present. So, thus the color of blue litmus paper remains unchanged. Okay. So, hydrogen ion in acid is the ion that responsible for acidic properties, which is sour taste, corrosive, has pH value less than 7, and change moist blue litmus paper to red. Okay, next, the role of water to showing alkaline properties. Okay, this one is the same step in experiment. Just we change the chemical substance from acid to alkalis. Here we have sodium hydroxide pellet. Then we add red litmus paper and observe the change. Okay. Then what happened? We add a water into the test tube. Shake well. Then we observe the change of red litmus paper. Okay. So now, based on observation, state suitable inference. Sodium hydroxide pellet does not show alkaline properties, but the resulting sodium hydroxide solution because we add water in the test tube, shows alkaline properties. So what is the condition of the litmus paper needed to detect alkaline properties? Red litmus paper must be moist to detect alkaline properties. Okay. So, is the hypothesis acceptable? Yes, we need water to showing alkaline properties. Okay, discussion. Name the ion responsible to show alkaline properties. Hydroxide ion. Write the name. Explain the difference in observation between using pellet sodium hydroxide and sodium hydroxide solution. Pellet is a solid solution, that means dissolved in water. So without water, the hydroxide ion in sodium hydroxide pellet cannot move freely. Okay, as they are bonded in its lattice structure. Thus, it does not shows alkaline properties. The color of red litmus paper remains unchanged. When sodium hydroxide pellets are dissolved in water, it will ionize and hydroxide ion will move freely in water. So, hydroxide ion that move freely cause the red litmus paper change to blue and show alkaline property. So, operational definition for alkalis. And alkalis is a substance that change red litmus paper to blue. This is what you observe. When the red litmus paper is dipped in an alkali that has been dissolved in water, this is what you do. Okay. So, our conclusion, alkalis only show alkaline properties in the presence of water. Without water, hydroxide ion in sodium hydroxide cannot move freely. So, does not show alkaline properties. The red litmus paper cannot change color. So, when the pellet of sodium hydroxide dissolve in water, hydroxide ion are produced and able to move freely. So, sodium hydroxide solution show alkaline properties. Red litmus paper turns blue. So, hydroxide ion also responsible for this alkaline property, which is taste bitter and feel slippery, corrosive, pH value more than 7, change moist red litmus paper to blue. So, from this lesson, you must know how to define acid, alkalis, basicity, which is we have monoprotic acid, diprotic acid, triprotic acid. And then by doing experiment, we can show the role of water in showing acidic and alkalinity of substance. Okay, so next, try to answer test yourself 6.1 and discuss with your class teacher. That's all the lesson for today. Thank you.